This is our Ski Watts presentation by Bella Iria and Christen Wu.
So our contenders, Margaret K. We have three kind of wax: beeswax, soy wax, and paraffin. We used the photo gate and the track was snow. We tested, and after we tested, we also mixed them into soy wax with beeswax, soy wax with paraffin, and beeswax with paraffin. And in the course of the experiment, we made a lot of problems, like for example, sometimes we just can't use the photo gate because it's not working. And so in the end, we choose soy wax with paraffin 1-to-1 combo as part of our race. So why we choose this wax on it? Because the Margaret K is decreased when we use this wax, and it's a very good condition. And how we did is, it's not that great because the velocity is not that fast.
Our results. So, our ratio was a soy to beeswax 1-to-1 ratio. What we did is we combined the two and we put it on the Watts torpedo. Pretty simple. Our run number 1 took 4.67 seconds for it to go down. This was after some technical difficulties, which I will discuss later on, but this was we thought it was a pretty solid run. We thought that next run we'll be able to do better. But we were wrong, because we weren't. Our second one went even slower, and that's okay, because we were only 0.6 away from winning, 0.6 seconds, which was kind of frustrating, but that's okay, because our torpedo made it down the hill. So last place is still cool. We didn't really care. We were just like, okay, we know what we did wrong. We know what we would do next time if we were to do this again. So, problem was, ours was really slow, and that's the main source of problems in our entire project, obviously. And a major problem at first was that it did not work. It would not go down the hill, and then we realized that we had it on the wrong side, so that was kind of ridiculous, but it's all good. It got down the hill. We got our data. We got 5th place out of 5 people, and that is okay. What would we do differently? We would probably use no watts, quite honestly. We would probably scrap all our calculations and data and just use no watts, because 1st and 3rd place, there were no watts. And the only reason why someone came in 2nd place, I don't really know, but it was so close that it could have been interpreted in any way, like experimental error, no watts becoming 3rd place too, but 1st place went to no watts. So our second point here is that we would test outside. So main source of errors here, we did not test outside. We only tested inside because we just miscommunicated, ran out of time, needed more coordination. That's all good. We were able to pull it together, get our calculations inside, but sadly, it was not 0 degrees inside, it was 70. So our watts could have reacted differently inside than outside, which is probably what happened. And we never tested no watts because we didn't even realize that we could do that. So that probably was another source of error. So 3, that would improve our data for sure. Just a whole different smorgasbord of things that we could have done but didn't, and it just kind of worked out. So 4, use different wattses. Even though no watts won, we would still want to experiment with different wattses. You never know, it could have gone faster with different kinds of wattses, maybe a mixture of all of them, different ratios. We used a very simple ratio. Ours was 0.5 grams of soy watts and 0.5 grams of bee watts, which made it so that it was very simple, 1-to-1, but that could have set us back. 1 watts could have been faster than the other, so you never know. It's a combination of things. So 5, clean our torpedo better. We learned from the no watts gaining 1st and 3rd that the better cleaned watts got a higher placing. It went faster. So you could have cleaned your watts torpedo better and then it would probably go faster, even if it had watts on it. So we would probably do that better. We cleaned it pretty good though. That's what I'm getting into in my next slide. So our torpedo, how did we prepare it for the race? So what we did is we scraped off all the excess watts with this scraper thingy. And then what we did from there is use the brush and did the length from back to the tip of it, of one side of it, and cleaned that, made it all nice, and then we used de-waxing oil stuff, and screwed the cap off, poured it on the paper towel, put the cap back on because it's poisonous and would have killed us all if it had stayed open, and then spread that everywhere, made it all nice and cleaned. And then we took 0.5 grams of each of our waxes, bees and soys, and then we put it on a hot plate burner, melted it, and then we took the cup out of the boiling water and let it turn into a solid, which was very, very quick process. And then once it was, we spread it kind of all over our wax torpedo, and then used a kind of ironing, melting thing to finish off the melting of it. And then we had our wax torpedo ready, and we tested it out a few times, and then finally raced it, which was cool. And that is the conclusion of this wax project. Overall, we were pretty happy just being able to get our torpedo down the hill at the end of the day. But we could have definitely improved in a lot of different areas, could have done different calculations, different wattses, no watts, whole thing. Overall, we're happy with how we did, even though we got last. And, if we were to do this again, we would be a lot more prepared, would have a lot better communication. And yeah,